What if you knew exactly how much a trade would make or lose before the market even opened? Before a single dollar changed hands, you could see your precise risk if the stock moved exactly $1, if a day passed, or if volatility suddenly spiked. Buying options by purely guessing the direction of a stock is like trying to fly a plane in pitch-black conditions. You might feel like you're heading up, but without instruments, you have no way to measure your actual altitude, speed, or fuel. Up until now, we've covered the cost of entry. The premium tells you what you have to pay to get into the seat. But once you own the contract, the forces acting on that premium change second by second. To understand those forces, you need the Greeks. These 4 Greek letters provide the data for your instrument panel. Every contract generates these variables to track value in real time. First, delta acts as your speedometer, then gamma, your gas pedal, theta is your ticking clock, and vega measures the incoming weather. Using these 4 inputs provides a framework to quantify market movement. By measuring the forces acting on your premium, you can manage a trade based on data rather than relying on a directional guess. Let's start with the offensive dials, delta and gamma. These deal directly with the stock's price. Delta is simply your option's direct sensitivity to movement. It answers the question, if the stock moves $1, how much does my option move? Delta gives a straightforward ratio on this table. A 0.50 delta gains 50 cents for every dollar the stock rises. It's also a probability scanner. A 0.30 delta has roughly a 30% probability of expiring in the money. But your delta doesn't stay fixed. As the stock price moves, your delta changes with it. You need a way to measure how fast that speedometer is moving. That brings us to gamma. Gamma is the exact rate of change of delta. If your delta is 0.40 and your gamma is 0.05, a $1 rise in the stock pushes your new delta to 0.45. A positive gamma mathematically accelerates your exposure with every successive dollar the stock moves. That acceleration creates immense risk for option sellers, particularly with 0 days to expiration, or 0 DTE, contracts. On the final day of a contract's life, gamma becomes explosive. A tiny move in the stock can violently multiply the seller's losses in a matter of minutes. Delta dictates if you are moving in the right direction. Gamma determines whether you're taking a leisurely walk or strapped to a rocket as expiration approaches. Now we switch from the offensive variables to the environmental hazards. These forces erode your option's value, even if you nail the directional guess perfectly. The first is theta, the ticking clock. For an option buyer, theta is a daily penalty. It is the exact dollar amount your contract loses simply because 24 hours have passed. If your theta is -5 cents, you lose $5 a day per contract, unconditionally. But if you are the seller, theta works in reverse. Think of it like a landlord collecting rent. Holding a short option with a positive theta of 8 cents means you passively collect $8 a day per contract, just for holding the position. The final variable is vega. It measures your contract's sensitivity to implied volatility, essentially the market's forecast for future price swings. This chart illustrates the devastating event known as IV crush. If you buy an option right before an earnings report, volatility is high. After the report drops, the uncertainty vanishes. Even if the stock price goes up, the sudden collapse in volatility can drain so much premium from the contract that you still lose money. This is the core paradox of buying options. You can accurately predict exactly where the stock is going with delta and still lose your entire investment if you ignore the silent bleeding of theta time decay or a sudden collapse in market fear with vega. Let's put the full panel to the test. Now that you know the individual dials, we can decode a live trade simultaneously. We will look directly at the Apple 185 call. We begin with the directional engine. Our initial delta is a positive 0.50. Behind it, our gamma sits at positive 0.04, ready to accelerate our gains for every dollar Apple climbs. But we have opposing drag. Our theta shows a constant bleed of -$8 per day, and our vega leaves us exposed to $15 of risk for every 1% drop in implied volatility. Look at how this combined risk profile graphs out. To make a profit, Apple has to move up fast enough, fueled by gamma, to outpace that guaranteed $8 daily theta decay, and we have to hope the volatility weather doesn't vanish on us. You might occasionally hear about minor Greeks like row and charm. For everyday retail trading, they rarely impact the outcome. Focus entirely on the core four. As seen with Apple, these forces never work in isolation. A profitable trade requires monitoring the interaction between direction, acceleration, time, and volatility simultaneously. You understand the mechanics now. You are no longer guessing. In Video 6, we start Module 2 by taking this exact dashboard and using it to execute the very first real strategy, the long call.